Today we're going to talk about one of my very favorite topics, probability. This is chapter 11 in our book. In this video, we'll talk very briefly about different types of probability, the fundamental properties of probability. We're going to talk about statistical dependence and independence, and I'm going to show you an example of expected value. I'll mention Bayes' rule, but we're going to save this mostly for class because it's easier to see with an example. There are 4 different ways to assign probabilities. 1, we can compute it exactly. This is sometimes called a classical probability or an a priori probability. A priori is Latin for prior to. So the idea is if we can figure out the probability before some event actually happens, then that would be an a priori probability or a classical probability, an exact calculation. So for example, if I have a coin, just a regular coin, and I ask you what's the probability of heads, and I don't actually have to flip the coin. You'll know there's 1 chance out of 2 for heads, so that probability is 1 over 2. In the real world, there are lots of things that happen that we just can't know ahead of time, so we actually can't compute exact probabilities or a priori probabilities. For example, my brother collects weighted coins. I can't just look at that coin and say, oh yeah, the probability of heads is 80%. I actually have to flip that coin, and I have to do it over and over and over and over and over and see how many times it comes up heads. And that's called a relative frequency approximation. It's sometimes also called an objective probability because I actually have to do it to see it. The third method to assign probabilities is called the subjective method, and we use this kind of probability all the time. Essentially, objective means we've tried it out, we see what happens. Subjective means we're not trying it out, we're just making a guess. If I say, I think Clemson has a really good chance to win their next game, that's a subjective probability. I think that probability is more than 50%. Do I have any data to back that up? No, it's just a feeling. When I say there is absolutely no chance she's ever going out with him again, that's a subjective probability. Based on my knowledge of the situation, I just make a guess. We can also do computer simulation to find probability, and this is fun, but it's not really in the scope of this course, even though there is a chapter about simulation in the book. So if you're interested in that, you could go and look at chapter 14. So some definitions that we need. An experiment is an activity that results in several possible outcomes, and those outcomes are called events. So flipping a coin is a probability experiment. Now it seems weird because we tend to think of experiments in terms of chemistry or physics. But for probability, if we don't know the result and then we do it, that's a probability experiment. A probability distribution is a list of all the events that can occur in an experiment along with their corresponding probabilities. So here's an example from the book. In this example, he made up 3,000 students at State University, and 300 of them made A's, 600 made B's, etc. And so those are just the counts. To come up with the relative frequency, we take the count for each grade and divide by the total number. So we had 300 over 3,000 for the A's, so that's 0.1, or essentially 10%. And then we use that relative frequency as an approximation for the probability. If I'm going to choose one student at random, I have a 10% chance of choosing a student who made an A. A joint probability is the probability that 2 things happen at the same time. So it can be written as probability of AB together like that, or it can be written as the probability of A and B. We can also compute the probability of A or B which is the probability of A plus the probability of B minus the probability that they both happen together. Now that seems like a typo that I put a minus sign there, but it is not. If I've counted an event, I've included it with A and I've included it with B, I've counted it twice. And so I subtract to avoid double counting. Here's just a quick example. I have event A, I have event B. If I want to add everything together, I add those two probabilities, but that area in the center, the purple space, that's the joint probability. That's the probability that A and B both happen, and I've counted it twice. I counted it with A and I counted it with B, so I have to subtract it. Sometimes events are what we call mutually exclusive. They don't overlap. Two events are mutually exclusive by definition when that probability of A and B, that joint probability, is equal to 0. If A and B are mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B. If I go to subtract that joint probability, it doesn't matter because that's 0 now. Another definition that is not the same thing as mutually exclusive is called independence. Two events, A and B, are independent if the occurrence of one doesn't affect the probability of the other. And then if they're not independent, we would say that they're dependent. So here's an example of dependent probabilities. I'm going to flip a coin, heads or tails, to tell me whether to take a ball from bucket 1 or bucket 2, and then I want to find the probability of drawing a blue ball. So that first event, that flipping the coin, makes a difference. It changes the probability of me getting a blue ball. If I flip heads on that coin, that probability of getting blue is 0. But if I flip tails on the coin, then I have a 1/6 probability of getting a blue ball. So we need some notation for this. We need to know the probability that B happens after we already know what happened with A. And that's called a conditional probability. We read this as the probability of B given A. We need to think about it as the probability of B given that A has already happened. It's already occurred. If two events are independent, then that conditional probability for B given A is equal to the probability for B. Because if they're independent events, whatever happened with A doesn't matter at all. So that probability for B doesn't change. The multiplication rule helps us find these joint probabilities. If they're independent, it's the probability of A times the probability of B. If they're dependent events, then that joint probability, the probability of A and B, is equal to the probability of A times the probability of B given that A has already occurred. This is Bayes' rule. The formula looks kind of complicated. It's actually easier to use than the formula looks. So I'm showing you this now just to tell you that this is what we're going to talk about in class. We're going to go over how to use Bayes' rule to find conditional probabilities. A very important concept related to probability is expected value. And this is important. We're going to use this again in Chapter 12. I personally think it's a great life skill to have. It really can help us make everyday decisions. And so we'll go over this in class too, but I wanted to do an example for the video. This is what the formula looks like. The expected value of a probability distribution is the weighted average of the outcomes. That's the definition, that's the formula. Essentially what we're going to do is if we have some procedure, some experiment, we're going to list all the possible outcomes and their probabilities. That's our probability distribution. And then we're going to multiply those probabilities by the outcome and we add them up. So we get a weighted average, weighted by the probabilities. So let me show you an example. I want to play a game with a die. If you roll a 1 or a 6, you win. But you're going to pay me $5 to play. If you win, I give you $10, but I keep your $5. So if you win, there's $5 profit for you. If you lose, there's $5 profit for me. So what's your expected value for this game? Or in other words, what are your average winnings? It's an average. It's a weighted average. So we've got two outcomes. You can win or you can lose. You win by rolling a 1 or a 6 on a 6-sided die, so that probability of winning is 1/3. The probability of losing is 2/3. I need to put some numbers with this. We want to look at your expected winnings, your expected profit. So what do you profit if you win? That's the $5. You paid me 5, I give you back 10, your profit is 5. If you lose, the profit is -$5 because you lost $5. So the expected value is the outcome, that $5 times the probability plus -$5 times its probability. And that turns out to be -$1.67. You might look at the $5 and the -$5 and say, no, those average to be 0. But that's not correct because I am much more likely to win than you are. So I am going to make money off this game, and you, on average, are going to lose $1.67 per game. It also means it's a bad idea for you to take me up on this offer. In summary, finding probabilities can be tricky, but understanding those formulas will be really helpful. If we know the probability, or we can compute the probability, we can use that information to help us make better decisions. And that's what's really important about this chapter and what's coming up in chapter 12.